Okay, this is it, the big video that describes everything we've done in Unit 7. First, we're going to start with, in our unit on equations and inequalities, writing word sentences as equations. We've already done word phrases as equations, and what we did this unit is we started to add the word is or equals, which gave us two phrases. Usually one was the answer, and the other was a word phrase or an expression that we then translated. So in this case, the sum of a number n and 7 is 15. Now we know the word sum means the answer to an addition problem, so that meant that n plus 7 is our phrase, and then equals is the word is, and then the 15 comes straight. So your equation will be n plus 7 equals 15. The big thing we need to concern ourselves with all the key vocabulary associated with this. And this is the same vocabulary we studied back in Unit 3 to help us to translate word phrases. Again, the order of those word phrases is very important, and the terms are very important. So, although all these terms are related to addition, it's very important to recognize these highlighted terms as what we called troublemakers. Because in a situation with a troublemaker, your terms would be reversed. So, for example, 3 added to x actually means x plus 3. That's the same with all those highlighted terms. The terms on the bottom, these are all the answers to these operations. So in the case of when you see the word quotient, it means division, but the terms will be in that order. So you'd say the quotient of x and 4 would mean x divided by 4. The product of 3 and 9 would mean 3 times 9. Now, although we know that addition and multiplication are commutative, we need to be aware that when we're doing a translation, a word sentence into an equation, we want to maintain the order that it's provided. The one exception is when you're using a coefficient. So we're going to do these three examples. The difference of m and 65 is 42 because the difference of means subtract. We're going to subtract. M and 65 are our terms. And then our answer is 42. You can see 5 less than r. Now, less than means subtract, but it is a troublemaker. So it's going to be r minus 5. It does switch the order of the two terms. And that equals 43. And again, the word is going to mean equals. So more than, you're going to have 8 more than v is going to be v plus 8 equals 14. Three more quick examples. Increased by means add. And so w plus 16 equals 40. We have of. Of means multiply. I don't think I put that on the previous term. We talked about that when you're doing a fraction of, a percent of, or a decimal of a number. It does mean to multiply. So we want to do half times y equals 70, or ideally, you'd write half y equals 70, utilizing the coefficient to show that multiplication. Fewer than is another troublemaker. We're going to make sure that we switch the order. Z minus 9 equals 21. Now remember, although many of these addition and subtraction ones were troublemakers, not all of them were. Increased by does not switch the order. If you see the word plus, it does not switch the order. So you want to be careful and make sure you're only switching the order when you should. Now, we also learned about how to solve algebraic equations. We learned all about the chronology of algebra instruction on equations and what you've learned throughout the years. And we now learn that the 3 steps we use are to isolate the variable by doing the inverse operation, then using the property of equality to keep both sides equal, and then check, plug in your answers to make sure that the solution is true. Here are 4 quick examples of addition, subtraction, multiplication, and division equations. You'll note when each of these are solved, inverse operations are used. So x plus 2 equals 10, you subtract 2 and cancel it out. Then because of the property of equality, do the same thing on the other side. X equals 8. I plug in the 8 to check to see 8 plus 2 equals 10. 10 equals 10, so we know that works. The same thing's here. Y minus 8 equals 10. We'd add 8, cancel it out, do the same thing over here. Because of the property of equality, to keep both sides equal. Again, we plug in our answer. We think that y is 18. Let's try it. 18 minus 8, it does equal 10. So again, we have a solution that we know works. 3 times n, note the coefficient. 3 times n equals 15. We cancel out by dividing by 3. That's the opposite of multiplication. We use the property of equality, do the same thing on the other side, telling us n is 5. We try plugging that in. 3 times 5 does equal 15, so we know that that's a correct solution. Finally, x divided by 2 equals 10. We're going to multiply 2 times x divided by 2. Cancel out the 2's, leaving us with x. Doing the same thing over here and getting 20. We plug in 20 divided by 2. It does indeed equal 10. And so we know these solutions work. Here are a couple quick examples again. We would add 7, cancel it out, bring down our y and our equals. Because of the property of equality, we'd add 7 over here. Our answer is 10. We plug in the y with a 10. 10 minus 7 does equal 3. We know that's correct. Z plus 3 equals 17. The opposite of addition is subtraction. Cancel that out, bring down our z and our equal sign. Because we subtracted over here, we're going to subtract over here to keep both sides equal. We think the answer z is equal to 14. We're going to plug that in, and sure enough, 14 plus 3 does equal 17, so we know our answer is correct. It's important to always check your solution because that's going to guarantee that you did it correctly. Now, 3y equals 36. We're dividing by 3 to cancel that out, leaving us with y equals. Because we divided this side by 3, we'll divide this side by 3. Y equals 12. And again, we're going to double check that solution and multiply 3 times 12. That does indeed equal 36, so we know it's correct. X divided by 7 equals 10. We're going to multiply x divided by 7 times 7. That leaves us with x equals. Because we multiplied by 7 here, we'll multiply by 7 here. We believe x is 70. If we do 70 divided by 7, sure enough, that equals 10. And we know that our solutions are correct. Now, another thing we'll end up doing is they'll give you an ordered pair when you have equations in two variables, and they want to verify that they're indeed true statements. So in this case, y equals 7x is our function, and we want to check and see if this ordered pair is a solution. Remember, an ordered pair always comes in order. So that 2 is your x value, and the 21 is your y value. So 2 times 7 is 14, and y is supposed to be 21. These are not equal. So this is not a solution to the equation. 2 comma 21 does not work. In this situation, again, this will be your x variable, and this is your y variable. So we're going to substitute the x for a 3. 5 times 3 plus 1. We're, of course, going to follow our order of operations and multiply before we add. 5 times 3 is 15, plus 1 is 16. So this is all equal to 16. This says y is equal to 16, and sure enough, this is equal. The equation y equals 10x plus 25 gives you the amount y in dollars in your savings account after x weeks. Identify the independent and dependent variables. Well, in this case, it's very easy to identify the independent and dependent variables because y is always your dependent variable. Your independent variable is always x. However, the same scenario could have been given with different variables. We want to understand what that means. The dependent variable depends on what the independent variable does. So obviously, you're making money for putting money in your account because of the number of weeks you're putting it in, not the other way around. So to find out how much money your savings account is after 8 weeks, we're going to substitute the x with an 8. And so 10 times 8 is 80. 80 plus 25 would substitute out to tell you that there's $105 in your account after 8 weeks. Now, we also moved on to inequalities, which was something new for you here in 6th grade. And we learned 3 new symbols. This symbol, which we know means not equal to. This means less than or equal to. This means greater than or equal to. We're already familiar with less than or greater than. It's very important as you prepare for the test to make sure you can read these symbols appropriately. Mixing up symbols could cause a failed test grade if you just go in the wrong way. It's not a good idea to learn tricks to remember less than or greater than. It's more about understanding what the symbols mean and how they work. All along, you've always known, oh, 7 is greater than 6. Maybe you even pretended it was a monster eating the larger amount of food. That's great, but all that does is learn a trick. We want to understand that greater than symbol is telling you the item that's to the left is greater than the number to the right. And so it's very important because as we graph items on our number lines, we need to understand what it means, not just to kind of memorize what it looks like. Remember, our goal is more about the learning and less about the numbers. So when it comes down to if you wanted to graph x equals 3 on a number line, it would look just like this. This example clearly shows the value of x is 3, and there's no value other than 3 for x. It's only right here. So if you look here at this example, you can see that it means that x could equal 5 or numbers less than 5. So you would say x is less than or equal to 5. And that's your first usage of the less than or equal to symbol. And that tells you any of those could be a solution. So if I say x is less than or equal to 5, you might say, well, maybe x is 5. Sure enough, there it is. Or maybe x is 3. That would be a true statement, and there the 3 is. The arrow is pointing in the direction of all the possible solutions. If I tried to list every number x could be, it would take me all day. Now, this example clearly shows that the number is greater than 9, but you'll notice this is not shaded in. That's because x is only greater than 9. It can't equal 9. And so understand when you've got an open circle on your line, it means it's not equal to that. Now, inequality symbols also need to be translated. We should obviously recognize is less than, is fewer than, is greater than, is more than. Note the word is comes before them. All these phrases we just used not that long ago with equations and expressions. And if we're using the phrase more than, that means to add. Less than means to subtract. But when we see is less than, that lets you know it's an inequality symbol, not a subtraction sign. Now, obviously, is less than or equal to, is greater than or equal to are easy. These are the ones that cause some confusion. Because obviously, you see the word most, you want to think you're going bigger than, but it's actually the opposite. If I told you at most the money you have in your account is $5, it means you couldn't have more than $5. Your value would have to be less than or equal to $5 because the most, it's $5. So, and the same thing goes with at least. If I told you I had at least $17 in my pocket, you would know that I didn't have less than 17, I have more than 17. So x would be greater or equal to $17 because I have either 17 or more than that. So be very careful, and instead of trying to memorize these, think logically when you read them. So in our goal here would be to be able to transfer these into inequalities. The number n is greater than 1. So n is greater than 1. Twice a number p is fewer than 7. So 2 times p is fewer than, less than, 7. The number w minus 3, so we're doing w minus 3, is less than or equal to. So this is all one symbol right here. So w minus 3 less than or equal to 10. So w minus 3 is less than or equal to 10. And then a number z divided by 2 is at least negative 6. So z divided by 2 is at least, we just talked about, means greater than or equal to negative 6. So to identify if 3 is a solution to this inequality, we're going to plug it in, and we're going to try. Is 3 plus 4 less than 6? No, 3 plus 4 is greater than 6. This is not a solution. We can try plugging the 3 in here. 9 minus 3. Is 9 minus 3 greater than or equal to 6? Yeah, well, 9 minus 3 is 6. That's equal to 6. So this is a yes, that is a solution. And then 18 divided by 3. Is 18 divided by 3 less than or equal to 10? Well, 18 divided by 3 is 6. 6 is less than or equal to 10, so this would again be a yes. Now we're going to be graphing our inequalities. When we graph inequalities, we want to take a look at what the symbols mean. These are a little hard to read. So x is greater than or equal to 2. Now remember, greater than or equal to means it could include the number 2. So I see two options where it could include the number 2. But remember, it's got to be bigger than 2. So B is clearly the answer for this one. So x is greater than or equal to 2. X is less than 2. X is less than 2. Now again, we know it doesn't include 2. So the only ones that don't include 2 are these. And we want the number that's less. So A is going to be your solution here. X is less than 2. This would be A. And then here, x is greater than negative 2. So let's think. Again, we know that it's not going to be either of these because these would include them. And this is pointing to numbers bigger. So then this one right here, x is greater than negative 2. And then this last one, x is less than or equal to negative 2. And you can see it includes a 2 and anything less. So x is less than or equal to negative 2. You must be careful with multiple choice graphs. on your test. You want to make sure you're carefully assigning your values and making sure that it plugs in appropriately. You'll be asked to graph your own inequalities on a number line. So A is less than 4. That's going to be an open circle pointing to the left to all the numbers that are smaller than 4. F is less than or equal to 7. That's going to be a closed circle because it could be 7. And again, pointing to the left to all the numbers that are smaller than 7. N is greater than 0. That's not going to be 0, but it's going to be numbers bigger than 0, pointing to the right. And then P is greater than or equal to negative 3. Okay, if it's greater than or equal, it's going to be shaded in and pointing at numbers larger than negative 3 because it could be negative 3 or more. Now, one-step inequalities have 3 steps as well, and they're very similar. You're going to isolate the variable by using the inverse operation. You're going to use the property of inequality to keep both sides true, and then you're going to check, plug in a possible solution. So in this situation here, I've got 3 inequalities. X minus 4 is greater than 5. We're going to use the same strategy. We're going to do the inverse operation, leaving us with X, but instead of bringing down an equal sign, we'll bring down the inequality. Then we're going to add 4 here because we're going to use the property of inequality, and that tells us X is less than 9. And we can go ahead and graph that. It's not 9, it's less than 9. Okay, and so any number less than 9, we could try one. Let's try 7. 7 minus 4 is 3. 3 is less than 5, so we know that's true. We can go ahead and subtract the 5 right here, and that would isolate my variable, leaving me with just h is greater than. Because I subtracted 5 here, I'm going to subtract 5 over here to keep the property of inequality, to keep the inequality true. So h is greater than 2. Now, with this situation, you've got h is not 2, but something bigger than 2. We can substitute a value. Let's substitute with 10. And 5 plus 10 is 15. That's certainly greater than 7. So we know that's true. With the last one, we're going to go ahead and add 2, which isolates my variable, leaves me with just y. And then because I added 2 there, I'm going to add 2 over here, giving me 5 is greater than or equal to y. Now this problem, because my variable ended up on the right side, a lot of people are more comfortable having the variable on the left. It makes it a little easier to graph. So we're going to do that. We're going to flip the whole thing around. First the y, then we're going to flip this symbol. So now it's less than or equal to and 5. And just think about that for a second. If 5 is greater than or equal to y, then y must be less than or equal to 5. Makes it easier to graph. We're going to shade in that circle and point to all the numbers that are smaller. And again, a number smaller than 5 might be 2. And if I substitute that, 2 minus 2 is 0, and 0 is certainly less, and 3 is certainly greater than or equal to 0. The same thing works with multiplication inequality. So we have 11k is less than or equal to 33. We divide this by 11, cancel it out. So 11k divided by 11 is k. We do the same thing over here using the property of inequality, leaving us with 3. And k is less than or equal to 3. We can graph that, and we can go ahead and have a shaded circle pointing to all the possible answers that could be there. Now, obviously, I could plug in any number less than 3. Maybe I'll go with a 2. 11 times 2 is 22. We know 22 is less than 33. So this would work for any one of these examples. I want to show you some division examples. You want to remember that you're using the property of inequality and you're using inverse operations. So m divided by 8 is less than 4. We're going to multiply by 8, and that leaves us with m. And we're going to multiply this by 8, leaving us with 32. So m is less than 32. Again, we can graph this. And again, we want an open circle pointing to all the numbers that are less than 32. You know, I could pick any number I want. I'm going to go ahead and go with 16. Over here, it's less than 32. If I do 16 divided by 8, that equals 2. 2 is less than 4, so I know my inequality works. This whole unit was a long unit of a lot of things you're not familiar with before now. Hopefully this video is a nice review, and I hope that you stayed till the end. I know it's a long one, and congratulations. Thank you very much, and I wish you well on your test.